monthly product focused training. We do have a full agenda today, so I wanted to get everyone or get kind of kicked off and going here. Again, thank you and welcome to everyone for joining us today. We have 3 products, 2 of which are going to be NPIs that are coming down the pipeline here. We've got the DF53 series, and Dave Gallagher is going to walk you through that. We have the HR22K, which is a circular connector that Carrick's going to walk us through. And then finally, we're going to do a product refresh on the TF31. So we've actually got some really good products to talk about today. We have the pleasure of having both Dave Gallagher and Carrick here, giving us a guided tour through those products. We're excited. A couple reminders for everyone. Please don't forget to mute your microphone. So background is when we're doing the presentation. Number 2, don't forget you have that chat button right up at the top, and you are more than welcome to post something in the chat. And the one thing that I do is I make sure that I'm keeping an eye on those chats. The presenters are kind of keeping an eye on them. And if I see a question come up and it hasn't caught the presenter's attention, I'll bring it up to them. So if you've got a question right away, kind of midstream, please feel free to put it there in the chat. We'll bring it up. We'll get it to the presenter's attention and answer those questions as we go. Sessions are always better when we have that interaction with the audience. So without further ado, I am excited to pass the baton here today to Mr. Dave Gallagher. Dave, awesome. Take it away, my friend.
Thank you much, sir, and welcome everybody. Appreciate you coming out today's training. We have some cool little products here that, and I'm going to stress that term, little product. In the first one, the DF53 series, are going to be covering today, and we'll get into some of those details coming up. Really appreciate the time. Just a heads up, we're not going to do those polling questions, which have been challenging for everybody this time around. I know that many of you were unable to participate in the last couple of sessions we had, so we're working on a future solution for this to help with that participation stuff. So we'll get those bugs worked out hopefully in the near future. And we were talking about that today and trying to figure out how to work around that Teams block. So we'll look forward to some future questions coming up. But as Scott mentioned, if you do have questions come up, please do put them in the chat box and do keep an eye on that throughout the presentation, and hopefully can get some great participation during the meeting. So our first product I'm going to be covering today is the DF53 series, and this is something that you may have already heard about in the past. This has actually been around for a little bit, but we're doing the official product launch on this product now because we've resolved some of the challenges on the manufacturing of the tooling. This is a really small product, and we didn't want to just put it out in your hands and have the customers be struggling to crimp this. So we've done some refinements on the tooling side of this and kind of held the product off waiting while we try to make it a little easier for the customer on that tooling side. So this product is very small, 0.6 millimeter pitch. And if you're familiar from our previous last month's session, we talked about the DF52 series, and that is a 0.8 millimeter. This is the next size down. But why don't you look at that second bullet here, up to 1.3 amps per contact on the 2-position version. This is amazing. For such a small connector, being able to handle that kind of power is a big plus. So we are extending the usage of the block-shaped contact within this connector, and that is a big plus for the design and performance of this product. So let's talk a little bit about what happens when you get down into these really small wire types of products. Traditionally, you see a shift from a crimp style contact to an IDC. And when you get into the really tiny wires, and you may have seen this in some of like the ganged micro coax connectors. Some of those offer like our DF36 and DF81, those type of series of products. Some of those products in that family, and not just from us, but competitors as well, offer support for things like 32 gauge wire. The downside is many of those using either solder or a IDC contact. And IDC sound great, but they're really restrictive in a couple of factors. Number one is if you look at that picture there, you can see how the IDC, it only touches some of the strands, and this limits the power capabilities quite a bit, 0.5 amps, as you can see here. So customers looking for handling a little bit higher current, maybe it's a battery application. This product with the IDC can't do that. So Hirose developed the DF53 with a traditional style of crimp contact, and we maintain that box shape that you've become familiar with in the past. And what this means is significantly higher current handling capability and, quite frankly, better durability out in the field long term. But it does pose some challenges during the manufacturing process as far as crimping. This is a small product, and crimping can be challenged. Not that IDCs at 32 gauge aren't challenging, right? And quite frankly, my opinion is that this actually makes it a little bit easier ultimately, because the customer gets a much more reliable termination in the situation. So how small is small, right? And here's a penny. We shot this picture yesterday afternoon, so sorry it's not been cleaned up too much, but it's a perfect example here. So we have our traditional DF63 contact. We see that much higher, bigger wire gauge size. So you can kind of see that in comparison to a penny. And if you can see off to the side here, we have our DF53 contact, and you could almost put this thing inside, in between a couple of the numbers on that penny. This thing is really small, and so that's hence when I talk about tooling, we have a applicator for a press, but this is not a contact that you want to be crimping by hand. If you think about the size of this thing, think about your fingers trying to hold that wire, that 32 gauge wire, inside of a hand tool while you're crimping. For this reason, there is no hand tool available on this product, and that's not by accident, that is by plan. We want folks to be using an automated crimping machine, like our CM105 series crimping machine, and an applicator, because that's going to result in consistent quality crimps on this product. And I mentioned tooling especially because we want to be talking to our customers about tooling. And when you're presenting and you got a customer looking for something pretty small, let's bring up that conversation early on about tooling. We just received an applicator here in the, I'm actually in the Downers Grove office today visiting, and we received it, I think maybe last week, we received an applicator in the office so that we can get practicing using it and get some prototype quantities built up on this as needed for particular opportunities. So let's take a look a little closer to some of these dimensions. 1.5 millimeter stack height off the board. So when you're looking at the height from the PC board, very low profile. Short depth between the receptacle and the socket plugging in, the back shoulder of that. Certainly is a very small space. Overall size is very small. And this is really meant for folks in, I'll say, the markets like wearables and some of the portable type devices. Maybe it's a set of headphones. Maybe it's something that's got little microphones in it and they need a couple of contacts for that. This product series is designed around that type of market space where space is tight. They got a need for 2 or more contacts in a very small available space inside their equipment, and they're looking for a reliable way to terminate. Usually when folks get into small wires like this, you often see hand soldering. And it's funny, yesterday we had a quick conversation. A customer of ours was talking about this just recently, and we were showing this connector within the last few days actually, and they were talking about how they tried this hand soldering method and it was a disaster, right? There was so much inconsistency. This is something that a connector does provide for the manufacturing, especially when they go from prototype stage to volume stage. A connector brings that consistency that you do not see in a solder-on type of situation. So have that conversation with a customer, do discuss that. With a really small product like this, certainly, whoops, I forgot to fix that little graphic error. Sorry about that on my text overlapping itself. When you're dealing with a small connector like this, precision is important. Hirose's known for this precision, right? You've all been familiar with our products and out in the field, and the customers have a understanding of the quality and precision in the design of our products. In order to build something this small, precision is critical. Clearly, Hirose's skill sets and manufacturing capabilities in small connectivity comes to mind. We have to make this thing so that the contact stays inside the housing, that the socket inserts and has good friction lock inside of the receptacle on the PC board. You don't want this coming apart in the field on the customer. And a lot of this has to do with the design of the contact itself. That box-shaped design, you've seen this before with the presentation that we did on the DF52. Think of this as just a smaller version of that same contact with that box-shaped design. This is very hard from a manufacturing. It took a lot of skill for our team, engineering team and manufacturing team to develop a consistent manufacturing process and make something this small. This is certainly a leading capability that we have at Hirose. Another cool thing that we showed you on the DF52 series that also carries over into this 53 series is that we have these little locator marks on the socket. And if the socket is not fully inserted, you'll have these little visible indentations that they can use machine vision to detect, or they can do a visual inspection to detect, to make sure that this socket is fully inserted into the receptacle. When that is done correctly, you will not see those contact slits on the outside of the housing. And you can see inside of it, they do have it on both ends of the connector spaced out so that it is easy for either machine vision or a person to see it, to make sure it is properly seated in place, preventing any future failures. Some applications, I wanted to show you one here. Obviously, computers, tablets. I mean, I got a new machine myself. It's got the camera, it's got the microphones, and all this stuff is buried into a very thin flange around the outside of the laptop housing. And this is where small wires come to play, small connectors come to play, and the advantage, you're moving away from the hand soldering over to a crimp contact. The assembly process is faster and much more reliable. Yes. In the case of some of these devices, you think of laptops, they might need repair in the future. Somebody has to change a screen out. You don't want to have to be dealing with hand soldered contacts. This is where a connector makes that process smoother and easier for your customer, whether it's the technician doing maintenance or repair, or it's the manufacturing process putting it together in the first place. So that's certainly a great market for this. Another awesome market for this is in the microphones and headphones type area. You know, we get tight spaces, things are getting smaller. You don't want heavyweight products. You're trying to remove some weight out of the, you know, maybe the headphones, or, you know, they got the goggles and the glasses, you know, doing on-screen displays and stuff, and cameras built into really tight spaces. This type of product is perfect for that. It takes up very little space, very lightweight, so low mass, which means that the weight of your overall product can be reduced by not having a bulky connector or not having lots of excess solder in there either. So the connector is very lightweight, makes that process a lot better for the customer's design. So keep that in mind when you're working with them. Other places you can see this, security cameras, any kind of camera product, right? You know, it's really microphones and speakers, small speakers, but you could also see this in small battery applications. An amp might be enough for a small battery application. Think of the medical market too. Many of these type devices are now showing up in medical markets, right? Where we have devices, tablets, and wearables. And wearables is another market space. You know, you talked about wearable headphones, but it could be a wearable medical device that is really tight on space, and hence a smaller connector is much better suited for those applications. And actually, I should brought it up the next slide where I talk about some of the other market spaces. You know, I mentioned cameras, there's security cameras, there's industrial machine vision cameras, multiple camera markets out there. Gimbal camera control, that's one of the pictures here. But believe it or not, even in industrial spaces, there are components that are getting smaller and smaller. Big, heavy industrial machinery is using consumer-style tablet devices for control panels, and sometimes they have remote sensors, or some of the sensor devices are buried inside. They got tight spaces. Hence, you may have a need for a very small connector in this market space. That 1.3 amps on 2 contacts is a great target point, especially for power applications that need to fit into really small spaces. So certainly a lot of applications available in the market space. Do have that conversation about tooling with customers, as I mentioned earlier, because when you get into something this small, we should be talking early on about applicators. If they say they're not worried about it, they should be. If they're saying they're just going to rely on their supplier to deal with it, they shouldn't do that. They should have that conversation to make sure there's a plan to get the applicator and get the tooling equipment in and do the crimping. So we'll make sure that we have that information is in the catalog, obviously, and as it has been before. But if you need assistance talking to your customer to convince them that they should be aware of it, this thing is really small. You saw in that picture with the penny how tiny it is. And we want to make sure we're focusing on having that conversation early on. General specifications, this comes right out of the catalog, so no problem from information-wise, voltage 50 volt rating, great temperature capability for those type applications. Certainly from a power handling, if you're using some of the higher pin count versions, that current rating does fall down a little bit lower there. So you want to bear that in mind if they're doing high pin count. But most folks, I'll be honest with you, have microphones and small speakers and small batteries. So they're looking 2 or 3 contacts is the size that I'm seeing so far in the inquiries that I've heard about. 32 gauge wire for this product. Mating durability is 20 times more than they're ever going to need for something like this. Typically, your insertion count's going to be sub 5 with most customers, so they won't need anything more than that in the applications. So that's the DF53 series, and this is in the process of final launch. There is information already up on our website. We'll be getting packages out to our distribution partners very shortly with all the information as we finalize and get all the paperwork and the I's dotted and T's crossed as we do this product launch. So super excited about this to finally get the word out. Be sure you're getting out to your customer fields, especially folks in the smaller products. Great product to be advertising to them. All right, so Carrick, you are now up with the HR22K series.
Excellent. Great presentation, Dave. Hello, everyone. I'm Carrick from Tampa, FAE for the Southeast with Hirose. Nice to meet you if I haven't yet. So I'm happy to present HR22K because it's a robust interface connector with high pin density. It can kind of be thought of as an extension of the LF product line because LF is a more established connector with variations, and this one is very similar to that one, with some advantages, of course. So as you can see on this slide, the outer diameter is about 20 to 21 millimeters. I just measured my thumb yesterday, and that's about the same size as my thumb, which is a little big for a thumb, but quite small for a 20-pin waterproof connector. The length of this plug is shown to be about 99 millimeters, about twice as long as my thumb or a similar connector, but that's because we're including that built-in strain relief, which is bendy, and the plug inside is about half that length. Don't let the black color of this strain relief fool you. This is a metal connector with a corrosion-resistant zinc alloy shell. It's not plastic. All you need to do to mate HR22K is push it on until you hear and feel a click. To unmate, you turn the sleeve a quarter turn and pull. Being able to simply push the connector to mate it is a strong selling point for customer technicians who wear heavy gloves while working. So here's my waterproof slide. This connector was made for harsh factory environments where water, oil, and cleaning agents are common. You can see the O-rings, the clamps, gasket that allows the connector to withstand full submersion in water. As with other waterproof circular connectors, a bonding agent like Loctite is used during the assembly process. While I have heard of some customers putting an overmold on the LF for strain relief, this HR22K has an already built-in strain relief, which we've tested, and Hirose's testing shows even after 1 million times bending the cable, there's no issues, no breakage. Lately, I have been receiving more and more inquiries for waterproof interface connectors that can handle higher speed data than before, like Ethernet. Other waterproof Ethernet connectors on the market tend to have about half the pins, twice the diameter, and similar pricing as HR22K, which is all to say this has a strong size advantage when compared with similar products that need that high-speed Ethernet. So at the moment, HR22K has one variation, uh, and this is that variation. But with that, I want to ask you a question. I think I might have just posted it in the chat. So what should I do if a customer wants a different variation of HR22K that is not available in mass production? Refer them to a competitor, check the Hirose LF catalog, panic, or tell them to change their design to accept the product we offer. And the answer is, of course, B, check the Hirose LF catalog, because again, this is a similar product which has many variations available at this point, like a right angle plug or male and female contacts switched on the sides. So this looks like a lot of words. I'll try to summarize it real quick. This connector has a shiny metal shell, nylon strain relief and insulation, phosphor bronze contacts, and something called hydrogenated nitrile rubber gaskets, which provide oil resistance. Under the performance characteristics section, you'll notice some typical specs for a 24 to 28 gauge wire, and then also a high mating cycle rate rating, which is important for something like this, which needs to be plugged and unplugged many times. That also makes it good to just have one sample you probably aren't going to break and have to replace all the time as salespeople. This product has contacts which are attached to wires using crimp machines. That is the version it is available in so far. And this part of the assembly requires a proprietary tool from Hirose, like the automatic applicator or manual hand tool, which are available. So this is kind of where the product was, why it was created. It's currently used in large robotic arms in factories which present a harsh environment. Ingress protection here is important due to all the dust, water, oil, and cleaning agents, which are common. The other main bullet point, again, is the simplified mating procedure. You only need to push the connector in to mate it, and there's going to be a click to indicate it's mated, but you could also give it a tug to double check because it has very high retention force. While it was created for factory automation robots like the last slide, I know you don't talk to only those types of customers. This could also find a home in any application that requires a compact and durable interface connector with 13 to 20 pins, such as radio, test and measurement, lighting, or lawn care. So that's what I have for you guys. Any questions, comments?
Questions for Carrick. Again, this is a robust area of our product line. We've got some really great circular connectors, and we've got a really comprehensive coverage between the products in this area. So any quick questions that anyone have before we transition back over to Dave?
Perfect. No questions.
Excellent. Carrick, you clearly have everyone mesmerized with your extensive knowledge.
Yeah, exactly.
Back to you, Dave.
Awesome. I was almost going to put into the chat box letter C for panic, right? You know, is that when you have that moment when you're in front of a customer and all of a sudden you go, I know I should know this little detail of this other product I got to present. And yeah, panic moment. So no, that LF series is a great pair to this HR22K. Really exciting on this design. Hopefully you can find some great opportunities out there for it. Really like that. Let me go ahead and see if I can get my slides up and running here for you on our, still loading for me. That's weird.
I
think you guys can all see it, but my slides are not loading on my screen. At least the advanced slide button is not loading. Hold on a second. I'm going to kill that for a moment here. And I'm going to just, we were joking earlier about, do you ever have any trouble with Teams? And I said, no, it always works great for me. Yeah. And it just made a liar out of me now. That's my punishment for saying that, Oh, I'll try not to do that next time. So, all right. So let's go ahead and get started. So we're going to be talking about the TF31 series today. This is a product refresh. The TF31's been around for a while. And but you'll notice here in the title line, we say FH12 to TF31. So what in the world, Dave? You said you're going to present the TF31. You got the FH12. What are you talking about here, right? So what we're talking about is that the FH12 series has been around for ages. And so, you know, we'll throw that little quiz question out there. And for anybody who knows this answer, non-Hirose people here now, you know, I'm hoping somebody in our distribution group here can throw this answer out. Do you know when the FH12 was actually launched and released? Does anybody know when that is? It's been a while, so you might have been in the industry for a little while. While you're thinking about that for a few moments here, I'm going to just say the FH12 series came out. Thanks, Dang. Not that old, but the FH12 was actually the world's first flip lock ZIF connector. Hirose actually invented the flip lock style of ZIF connector. If you think back, before that was an option, you had lift style connectors and you had slide tray style ZIFs. And there was, you know, some variations out there, but the reliability of those type connectors wasn't great. And Hirose has certainly built tons of these. I love the little sign here. We got our billions and billions served, right? We have produced amazing quantities of FH12 connectors over the years. Still a very popular product line. And I didn't see anybody else other than Dane throw a date in there. You know, no guessing in there. All right. So 1994. So yeah, it's hard to believe it's been that long. 1994 was when the FH12 series came out. And is absolutely one of the most popular products out there for that. Oh, Pat, you got it in just under the wire there before I said you were very close. Thank you very much. 1993. So so close. You're just off a little bit. We probably started talking about it in 1993. Would be my guess, right? You know, knowing how we tend to operate with stuff. But there's certainly a lot of options out there. But here's the bad news. Sorry news here. We would like to start transitioning people away from the FH12. So if you're doing new product designs, really we would prefer if you did not highlight or focus on the FH12. It's kind of starting to get a little old here. And it's really time to start moving on to some newer style connectors. And that's where the TF31 is coming into play. It's part of the series of products that really pairs nicely as a replacement or upgrade or future design in to start replacing out FH12 connectors in the field. So when you're working with new designs, please do try to point out the TF31. If a customer has been using the FH12 in the past, we want them to be starting to look at some of the newer style options that are out there. And I'll tell you a little bit in a moment here how to make that a little bit easier. So the TF31, very similar size options, 0.5 millimeter pitch style, and there is also a 1 millimeter pitch style. A couple of different heights off the board for this. It is a bottom contact, and it is a front flip. And if you're not familiar with front flip style, basically what we're talking about is the flex comes in on the same side as the actuator opens and closes. They call that a front flip style. And certainly that is popular. The other style you might hear about is a back flip. It's where the flex comes in on the front and the actuator actually opens and closes on the back side. The TF31 series is a front flip style connector. And that makes it a little bit more traditional in the styles that you're going to see. And just for comparison, so was the FH12. So one thing we want to point out here, if you have a customer that is, they've done their design, they're looking at the FH12 and they've already laid out their board, there is some footprint compatibility between the FH12 series and the TF31 series. And so we got a little graphic here to kind of highlight the really key feature on this. And I just want to point this out. If they were using the FH12, this purple kind of spot, purple pink, depending on how your monitor color shows up here, this is what the FH12 pattern would look like. So a nice big block on the side here. It would be for the mounting portion of it. And then for the data contacts themselves, they're a little bit longer in their design here on the product. So the contacts for the TF31 will touch into the same area and space on the PC board, and this is both on the mounting contact point and also on the data contacts. It will fit and operate perfectly fine between the FH12 and the TF31 series. And so if you've got a customer working FH12, they got a board design, they're about ready to go to final production, and they already designed it around the FH12 design, you can still make the switch over to the TF31. It's okay. They do not have to respin their board. They'll still mount onto that same profile on the PC board. Let's talk a little bit about the dimensionals. Yes, sir.
Yeah, and so question in the chat box, and I think you're addressing, I just want to make sure, are these all PCB compatible to FH12?
Yeah, so
the
FH12,
is that what you're getting to?
Yeah, that's what we're talking about. So the TF31 and the FH12 are compatible with each other. And I want to stress something here. There are other variations of the FH12. There's like subset letters at the end of that. I'm talking about the FH12, just the plain FH12 family, which is the right angle style of this connector on the board mount. That is the variation. It is compatible with the TF31. There are other variations of the FH12 that are not, right? So we want to be careful. There's like an FH12A and a couple of other variations of how the flex enters into the connector and where the contact is located. We're talking about the basic FH12 bottom contact style, which is what the TF31 is. So that's why we're focusing on that group of product family. So yeah, PC board compatible. You don't have to change the layout on your FH12 to make the switch over to TF31. I'm not looking for you to go out and find all your FH12 customers and convert them over. Although, you know, if you've got somebody that's going into prototype and initial development and they've already been looking at the FH12, that's a great time to make that switch, right? And they can make that switch over to TF31. And when we also talk about like dual source potential, right? If you have a customer that's, you know, looking at the FH12 and they're a little short on inventory, the TF31 will plug into the same layout on the board. Just bear in mind, there are some minor differences on the flex itself that we'll talk about in a second here. So I'll get to that portion of it in a moment, so don't worry. So let's talk a little bit about the dimensional side of this. The profile, the standard profile on this product is 1.75 millimeters off the board. You may have noticed at the beginning, we talked about 2 millimeters. There are some pin counts, especially when you start getting over 20 pins. We see pretty consistently the height of the connector, because it's wider, the actuator gets a little thicker, and that will run up to 2 millimeters. I'll show you in a chart in a little bit here that talks a little bit more in detail. Certainly that information is available in the catalogs as well to provide you that detail. But we have a nice, fairly compact size connector. It is a little bit smaller than the FH12, so that is nice with the TF31 series. You're not worried about taking up more space on the board. You can kind of see here, let me start off with this height variation side, because that's what I was just talking about. 1.75, you can see right up to the shoulder here. Some of the higher pin count versions of this, the actuator gets a little bit thicker, and you can kind of see that in this picture here on the right-hand side. So it gets a little bit thicker on the PC board because it's longer. So you need a little bit more strength there, and that goes up to 2 millimeter. I'll give you a little bit more detail on the next slide. The other thing I wanted to mention on this slide is pitch variations. We have 0.5 millimeter pitch, and then we say that we have a 1 millimeter pitch. What we've done here is we've taken the connector and we've designed it with it's skipping every other pin. So I want to stress right at this moment, and it's because it is skipping every other pin. There is a 0.5 millimeter offset when you're doing in the flex design. So the details are in the catalog, so don't worry. It's on the drawings and catalogs. We provide very good details for your customer to identify the design. But it is basically a skipped pin version of the 0.5 millimeter pitch design. I wanted to show you a picture of that. Looking at those pin counts versus height, you can see here at 0.5 millimeter pitch, it kind of starts around that 21 pin value, and then that goes up to 2 millimeter stack height. In the case of the 1 millimeter version, there's a couple that are at lower pin counts that have the higher, the thicker actuator bar. So you can see here a little check mark under the 2 millimeter stack height. Lots of pin count available on the TF31 series. So you can see that right here. There's lots of pin count options available in that series. So you should fit any of the applications that your customer's working on. One of the cool things about this product here, key selling feature, I'd say, is that it's got the side catchers. This was not an option in the FH12. And during my preview call with our internal team, One of the questions that came up was asking, can you use a non-tab flex inside of the TF31? The answer is yes, you can, right? Just bear in mind the retention force is lower. The goal of the side tabs is really to improve retention, number one. Number two is to help with the alignment, right? You know that it's seated in there properly and it's not going to be crooked. And that's a big benefit of those side tabs inside the product. The other cool thing of this product is the actuator opens very wide. 110-degree swing range makes it very easy to get the flex in and out of the connector, more in than out, because during the assembly process, you want it to be as easy as possible for the manufacturing team to get that placed in there. And that's what those side catchers help with. They catch onto that shoulder and keep that flex loaded in there. The other cool thing about this is that the actuator is very well supported. Hirose is known for this. We have very durable actuators. One of the concerns we get here out in the field with some of our competitors' products is actuators break. If you hear that, and I'll tell you, my automatic response is, yeah, I'm guessing that wasn't a Hirose product, right? You're talking about one of my competitors' products. Yeah, we're not using Hirose, and I really don't like using Flex FFC connectors because they break easy. You really need to try out the Hirose products. We spend a lot of time in the engineering team focusing on making sure that the mounting for the actuator on the inside is very strong and durable. There is a little bit of a interference when the actuator closes to kind of latch it into place to hold it down. That's within the scope of the design, so you're not worried about the actuator popping open on folks. That is a big benefit for our design on the edges of the connector. So this is something that Hirose does that not all of our competitors do, that ensures that our product is going to be performing significantly better in their manufacturing situation. So a little bit more about the flex design. When you're working with customers, yes, it is PC board compatible. You want the customer to take a close look at the dimensional data on their flex. Some of the tolerances that we've provided on the old design were wider than it is today. Flex manufacturers have really gotten excellent capabilities these days for tightening up tolerances, and as a result, the industry trend has been towards some tighter tolerances within the scope of that. We want to make sure if they're building it, they want to do the side catchers. It's a good opportunity to review that. They may want to do the process of replacing their flex with a side catcher design that is a little bit more excuse me, sorry, a little bit more durable in their application. Some great capabilities on this product, from a materials and performance, 0.5 amps per contact. This is an excellent product for most applications. I've seen, and speaking of applications here, I've seen this used in a variety. I have somebody in the audio industry using this connector. We got all kinds of customers across a very wide assortment of industries that are using the TF31 product, whether we're talking consumer electronics or even industrial and medical equipment. I'll say the office style equipment market space is a big user of Flex. I have also seen this type of product used in things like conference room controllers and desktop display systems, stuff with keypads in it. Those type of applications where you're typically going to see Flex used a lot. If they have maybe tight bend radiuses they're dealing with, they might be using Flex in those applications. TF31 is an excellent product to consider for those market spaces. So start talking to your customers. If they're using FH12 already and you're going through prototype phase and they're pretty happy with it, great. Let's get them over to TF31 and get that installed in the design. If they're going through their prototype phase, if they're already using the FH12, don't worry, we're still building them. But we are looking to start transitioning customers over to a new design whenever we can. We're not going to push folks to it early on, but just be aware of it so you know that it's coming down the road. Eventually, we are going to start discontinuing the low volume movers and start getting people to go, kind of push them along to the TF31. So if you have a customer you're visiting regularly that uses the FH12, maybe it's a good time to start having that conversation about when is their next development schedule looking like, and maybe we should be looking at the TF31 for the future design. Don't worry, you don't got to change that board layout, but we might want to take a look at that Flex, and it's a great opportunity to put those side catchers in place. So I didn't see any additional questions in the chat box so far. Are there any other questions, whether it's on the TF31, HR22, or DF53? Now's a great time to toss those in the chat box or let us know.
Okay. chance for those additional questions. We got about 3 minutes left to wrap up here. Any additional questions before we finish up here today? Will you be sending out end of life notice?
Yeah, when the time comes that we start making that change, we will definitely get the standard notification process out and help support you through that process. I'm not expecting it in the short term, but as time goes on and we start seeing, maybe the low volume runners, we'll start picking off some of those. Hirose has an excellent EOL process in the sense that we do have a notification that goes out to our distribution partners. We also register products with some of the part search systems out in the field. We do put our parts out into those search systems with this substitute. So certainly your customer will be aware of it, and you will be aware of it when the time comes. I see another chat question in here. Why do we offer 0.5 millimeter and 1 millimeter pitch? When would an engineer prefer a 1 millimeter pitch design? I'll be honest with you, 1 millimeter pitch is kind of an older design, right? And we still see customers that they really are not looking for the space savings that on the flex, and they may be used to using 1 millimeter pitch. Time came along where folks were looking for smaller connectors, and hence 0.5 tended to be more popular today. And if you were to look at most board layout designs, that 0.5 and honestly 0.4 too on layouts, you see that a lot in the industry. Whereas 1 millimeter is kind of a little older school style. We certainly do see folks moving over to the 0.5 millimeter pitch. There isn't anything wrong with 1 millimeter pitch design. If you have a customer that's using it, they may find their flex is a little less expensive in that case, depending on their flex source, and which that might be the incentive for them. But if they are, I'm really seeing the trend going to that 0.5. Long answer for a short question. Sorry about that. I'm known for that.
No worries. Okay, with that, then we will wrap up today's session. Just a heads up, normally we do it the second week of every month, but just due to some conflicts with resources bumping up against the battery show that will be happening the second week of October, we did move the next product training session up to the first week of October, so it will be October 2nd. So look for that invite coming out to you shortly for our next product training session. And just to be aware, we did move up 1 week this month. For this week, we are right on time. It is 1:45, and I'd like to thank everyone for your attendance and participation today. As always, don't be afraid to reach out to your Hirose contacts if you have additional questions after the meeting, and just remember the session will be posted on our extranet should you need to access the information that was presented. Have a great day, everyone, and we'll talk to everyone again soon. Bye-bye.